All right. So we're here with Matt. Can you introduce yourself? What do you do?
I'm Matt Pietrek. I'm an architect with the Visual Studio team. I work, the large subgroup I work with is under Team Foundation, or not Team Foundation Server, but the Visual Studio Team System. Team Foundation Server is part of that. Also, other parts of it like for testing, and in my specific little subgroup would be the profiler, diagnostics, debugger, that kind of stuff. Yeah.
Excellent. For Visual Studio Team System.
For Visual Studio Team System.
Now, that's the same debugger, right? I mean,
it's just the same debugger. The debugger itself, I don't actually work on a debugger proper, but I work closely with that team. The debugger actually is part of Visual Studio Pro, and wherever SKU the debugger is in.
Cool. So what do we want to talk about today?
So today I'm here to talk about what we're doing with in the diagnostic space, hopefully some future leaning things without getting too far into product details.
Sure.
Two big things that we're doing is, number one, we're looking at the diagnostic space above and beyond what we're doing right now, and the other one is some efforts to hopefully allow other partners to leverage what we have in the diagnostic space. So I could talk in more detail about those, but
sure. But
sort of the key point of all that is that we're definitely ramping up. We have plenty of opportunities. We're hiring. It's like everybody around me is like, hire, get some people, because we've got some really great stuff planned.
Excellent. Yeah. So what are some of the challenges with diagnostics in a team system environment development?
So probably the biggest problem, and the one that I've actually been focusing on in sort of my research role, has been how do you diagnose problems that are not, don't happen on the developer desktop. It's easy enough for the developer to get their standalone app or their distributed app. It works great for them. But what happens when it's out there in deployment? What's your debugging story? It's, if you're lucky, you get back some logs. Developers may or may not talk directly with the operators, the people who are collecting this data. And there's just a whole multitude of challenges relating to that. And so, and it's not just, gee, if I could attach a debugger to the point where the production system failed, what if it wasn't set up properly? I mean,
sure.
The developer may have assumed, you have ASP.NET set up and configured this way, but was that requirement even put into a requirements document that an operator would know to configure it that way? So it's not just why did it fail, or was it something in your code, but it could also be what was the configuration, or any number of a collection of problems.
Sure.
And even within that space, the tools or the approaches you might take are going to vary radically differently from like a Morgan Stanley, say, that has line of business apps, web forms, versus like an Amazon, which is most of the development is around web services. The sort of the tools the tools and the focus of what you're going to want to do are going to differ for that.
Sure.
So that's in the general case, that's the
problem space.
Yeah, that's the problem.
It's pretty big.
Right. Yeah.
So I mean, how do you work with distribution in that sense, like you're talking about? So I mean, clearly there's on a developer. What if you have a multi-threaded application and some random error happens? It's always hard to debug.
Right.
But especially in the distributed case.
Especially in distributed.
So how are you what? So what kind of things are you doing in Team System to make it easier for developers to solve the problem space that you're working with?
Well, at the moment, there's no specific tools that address, say, like the multi-threading issue,
Sure.
but that's definitely where we want to go.
Okay.
So not only have I been working on distributed diagnosis, but we also have somebody else who's been focusing on the whole issue of concurrency. And we've looked at, gee, what are some things we can add to the debugger? How can we make the debugger a better thread-aware debugging experience for you? And what tools can we put out there that might help you find race conditions and so on and so forth?
Sure.
So there's a lot of effort there, and it's like we've got a relatively small team, and we have far more opportunities than we have people at the moment. So.
Sure.
So yeah.
Cool. So you're hiring. You hear that, Niners?
Yeah. We're hiring. You know, I've gone out and I've put posters up, and I've even gone over to found the Windows Diagnostics team over in building 26, I think, and managed to drop a poster right in the midst of their little group, which caused a little uproar. But
cool. Now, this brings up an interesting question in the sense that, for example, on a product like Windows and Windows Server,
right.
you clearly have teams of people working in a similar product space, right? Like they want to know when you have enterprise class server clusters and all this distribution everywhere. I know there's teams that are working on management side of things. So are you working with them at all?
We do work with them. You know, they're at the moment they're sort of very heads down in Vista and so on and so forth.
Sure.
But like we just had a very productive meeting with with their diagnostics group, and we found out they've got some current efforts going on that we definitely should be a part of. One group that I've just joined and have actually been involved with in prior groups, related groups, was like distributed diagnostics tracing. Like we have out there, you can do this in Indigo today, and we want to sort of have the whole company do this kind of stuff, is putting traceability, diagnostic ability into your code in the form of, think about it like injecting dye and watching the transaction as it flows from, like, say, the browser to the web server to the database to the DCOM component or whatever, is that the ability to essentially track a transaction or the logical thread of execution as it goes across all these pieces. And that's actually where a lot of my effort has been in. And we have some cool prototype code that does some good stuff. It's if you believe the Indigo Trace Viewer is out there as part of the would be think that, but then think of some other really cool things you can do on top of that. And we have demos of the stuff; they're just not ready for public consumption yet.
So can we talk about a little bit how you implement this dye tracing? That's a great analogy. So you're a software architect.
Right.
You write code.
Right.
You're an engineer.
Right.
So how do you go about implementing something that's already out there, so we don't get into your IP issues?
Right.
Like, how does that work?
Well, that's actually a good story, or a good question. One of my other sort of pet projects that I hope to ramp up on even more is basically giving good guidance. We have a prescriptive architecture team, but giving good guidance on how do you I have an existing app. How do I basically instrument it? How do I put in information that some sort of logging tool can use? We have a variety of stories out there. Systems.diagnostics.trace and ETW. SQL has this bid architecture, a variety of ways that you can emit trace information. But what they really need is a consistent way, and a unified way of saying, when a client, was saying, I'm doing this logical activity, I'm going to transfer control to a server component or to the next component, and I want to convey what that server activity is, so that the server or the logical thread activity is, so that the server component can pick it up, and it can log it itself. Basically, if every point along the path of the logical thread, if it all emits tracing and it all has a sort of consistent, well-known format, which we call activity IDs, if everybody does that, then you can write tools that take these and process them and show you sort of a coherent view of the application across the system. One of the cool things I've been working on is the ability to do that tracing. Is like, assuming there's built-in tracing that does this, is to take that and actually correlate it back to source code. So it's one thing to have a bunch of printf style, this happened and this happened and this happened and this happened. It would be that much cooler if you looked at something and it showed you the associated source code with that.
And that would require symbols, though, right?
That would require symbols.
Debug.
Yeah.
So that brings up a good question again, in the sense that most of the most egregious problems that people face, or the most important ones, are happening in production code. Right. So you're compiling it not as debug.
Right.
And clearly you can still trace and stuff like that.
Right.
But you're saying that you're adding something a little bit more robust than trace that will work for production code.
Yeah, we're not at this point. We're not focusing on the adding the tracing part. There are other parts of the group at a company that focuses on tracing. We're more of the, if we can get good tracing for people's components, we're there for you, and we have some really compelling demos that I wish I could tell you more, but everybody.
That's fine. We'll come back when you can. I mean,
yeah.
This is a good intro, just to the to the problem space.
Right. Yeah, and then the other sort of big problem that we're working on, and the group that I'm part of, is that we have within our group we have the debugger, we have the profiler, and we have static analysis tools, and there's a lot of shared code in there. Like the debugger needs to know how to read symbol tables. The debugger needs to know how to access line number information. The profiler has similar needs. Debuggers and profilers are sort of logically derived from the same sort of base set of technologies, and it's like in my project, we'll add even more sort of base technologies in there, and it's like right now, like each product sort of builds its own little silos, but we're thinking, what if we built an ecosystem, or if we broke apart these technologies and made them sort of as components that we could plug into, and that our products would be built on these sort of components, but then partners or third parties or ISVs could leverage these components themselves. And the whole model of how it would work and what a program would be called and all that kind of stuff, that's still up in the air. But we're we're thinking now about in the whole diagnostic space, componentizing it so that people can build custom solutions, especially ones that maybe aren't a mass market solution, but that have a very applicable use for a narrow segment.
Excellent.
Yeah.
Now, does managed code help you with diagnostics? The fact that it's verifiable and et cetera, et cetera. I don't know. I mean, does that help you?
Managed code is interesting. I certainly try to use as much managed code as I can. If I'm writing sort of high level algorithmic processing or whatever, I would love to write everything in C#, assuming except for when I need to get down to low level.
Sure.
But it's actually interesting. Is we'd like to think that a lot of the world's moving to managed code, and it's the new world. But the fact is there's still native code out there. There's still pieces of SQL are still predominantly native code. Pieces of IIS are still native. There's lots of componentry out there, and it's a very mixed world. And what makes it challenging for the diagnostic space is that we can't just focus on just the native story or just the managed story. So, I'm actually down in the blood and guts of COR calling conventions, what parameters are passed in registers, and just the fact that you might use detours to hook a native function. Place assembly level place a jump on an instruction and go off. But for managed code, you have to use the profiling APIs or your own IL instrumentations. It's almost like two completely different rules or universes of how these things work, but we need to try to make the diagnostic tools that extract away that difference is. And,
absolutely.
So a developer, this is my code. This is what happened. And
sure. I mean, that must be incredibly challenging when you have a managed process hooking into an unmanaged process. There's a problem that happens somewhere along the way. You have to figure out what it was and then demonstrate it nicely in your UI, in your diagnostic tool.
Mm-hmm.
And if you want to actually point to code, that could be pretty hard.
That is a particular challenge. It's like if you've done native diagnostics, you're used to you have an address, I can pass it to some symbol table code, and I can get back a source file and a line number. It's not quite that simple with managed code.
Cool. So, do you have anything you want to show us today?
Oh, I wish I could. If we were a little,
have to ask.
Yeah, you have to ask. We've actually had some system design reviews, and we've shown the project I've been working on, and it's a really compelling demo with showing ASP.NET and Indigo, and everybody who's seen it has raved about it. It's just not quite ready to show. So, do you
have a blog or?
I do have a blog.
Okay.
It's the MSDN. I think it's Matt Pietrek, and I talk somewhat about what I do here, but it's sort of tell stories from the past and from previous from my work with CompuWare and stuff and things like that.
So. Okay. So as Channel 9, we cover a lot of different developer style roles. And it seems like software architect is one of those roles that's very nebulous.
Right.
Precisely. Because you know what an SDE,
right?
And the software developer, design engineer,
right.
It's kind of an understood role. But
right.
software architects, you tend to vary.
Right.
Some of you even have like teams, but not always.
Right. Yeah. In fact, I'm part of a team. My manager himself is an architect.
Okay.
And so the question is, how does that work?
Yeah.
Yeah. That's actually people ask me what does that what is an architect? How is that different from a developer? And I think it's actually I think about this question a lot, and a lot of it is just like an architect has, in my mind, is sort of like should be to have the skill set of a good developer, but also be able to act as a PM, and also have the ability to communicate well. I'm not saying that the other ones can't, but sure. But for example, in just my current project, it started with an idea, and my manager's office. He said, "What if could we do like this?" And I think we can. And it was a matter of sitting down with literally just an idea and figuring out what are the capabilities, what do we want to build, how might it work, what are the pieces, and then he gets signed off from everybody. Like, yeah, that sounds good. And then I sat for like 6-7 months, which was my primary role was basically as a one-person development shop. And and everybody else around me is working on WinB and heads down cranking on WinB, and I'm like, okay, I've tried to take a fairly large concept and just connect the dots to build a working prototype of it. But then at some point, as it comes together, I'm because we're understaffed. Our the available PMs we have, they're focused on WinB, so to take that role and go, okay, let's go get involved. Let's go talk to the ASP.NET people. Let's go talk to this group or that group. Get them involved. Get their feedback. I've been talking with the mom team an incredible amount, with their architect, and like, okay, what would integration between mom and my thing look like? So some days like I feel like I'm a PM, and like I'm sitting here in Outlook and scheduling meetings, and who needs to go connect here, and so there's the developer role, there's the PM role, and then I wrote a Think Week paper, the whole Bill Gates Think Week paper. I wrote that. That was a.
Did he give you feedback on it?
I don't know why. We somehow missed it on that one. Everybody else who read it loved it. So somehow Bill didn't get to my Think Week paper. But I got very good feedback on it, and it sort of has effectively become like the calling card for the project. You put out. Go to the Think Week paper first. So and that was a fair amount of writing. And it is lucky because I have a lot of experience. Having been a writer in the past, I was able to take a bunch of ideas and craft basically a mission statement or a Think Week paper out of it.
Sure.
So yeah, it's a bunch of roles. It's knowing being able to be a fairly good developer. Being able to act as a PM when necessary. Being able to communicate your ideas and to offer feedback to others.
Sure.
And, look for integration points and stuff. So sort of, it's a very sort of outward focusing thing rather than a sort of an inward, what do I need to do type
cool.
role.
And so then when you actually have a team of developers working on this project, you'll act probably as the lead developer helping out, or will you be an individual contributor?
Well, that's actually that itself was a subject of a lot of internal discussion. What is the role? There was a big thread on it, and I think some architects, want to code. They want to still be down in their trenches. I don't know if they want to necessarily be the lead developer because we have dev leads and they have a lot of the same attributes as an architect, but their job is get that thing, get it defined, get it out the door, and so they're focused on what's the release now, whereas we're thinking about what's the current release, what's 2 releases out. Yeah. So, coming up as this, we hire people and get my current project, going. I've actually been discussing this with my manager is what's my role? Is should I take on some amount of coding, maybe just the incredibly tricky part that I understand and it's just hard to convey, or what? But I think it's important for the architects to keep their hands dirty. Be fighting the compilers, alongside everybody else, and just I don't want to be one of the circles and arrows guys who says whiteboards filled with boxes and can't implement something.
Well, yeah. Well, I mean, agreed. I mean, you're an engineer, right? So
yeah,
that's what distinguishes you from a PM role.
Right. Yeah.
Excellent.
Yeah, and I'd actually started out here I came in as a software development engineer and essentially had to earn my way up to be.
So how long have you been at Microsoft?
I've been at Microsoft for a little over 2 years now.
Okay.
And came from CompuWare. I worked on Bounce Checker series of products.
Okay.
Yeah. So sort of like my whole career has been spent pretty much in diagnostics.
Excellent.
Yeah.
Because I mean, it's a natural that you're working in the IDE. Because that's pretty much the future of our development platform. Right. It doesn't mean that unmanaged code is going away. I mean, Visual C++ WIDBE is excellent.
Oh, it is.
But they still rely on the core diagnostics of Visual Studio, right? So they plug into the same thing, which is a really nice story. Excellent.
Yeah, and and one of my sort of favorite parts of managed code, one of the sort of things I absolutely rely on is to manage C++. Is sort of like it's that lifesaver of I want to write managed classes and use the BCL and all that stuff, but it also managed C++ also lets me call the 132 APIs and basically makes it seamless. So I'm not having to do the P invokes and getting the right declarations right or whatever. I just write the code and especially with the WIDBE, the C++ 2.0 syntax. There's big chunks of my project have been this part I'm doing Windows stuff, but I want to drop it in with something that's all very managed code. It's just write a C++ assembly and I'm good. So I love that.
Excellent.
Yeah.
Well, that's great.
Yeah.
We've been trying to talk to people who are actually using Visual C++ WIDBE.
Yeah.
Done a lot of interviews with that team, but it's nice to see that actually here we have someone who's using it.
Yeah.
And talking about one of the things that they market.
Yeah. Yeah, and it's nice, and it's nice to actually be able to use the IDE now, because it's one of the big differences between here versus the outside world. The outside world is you get a new IDE every 2 years or 3 years or whatever the time frame is, but that stays steady. And one of the challenges we've had here was during the WIDBE time frame is that we were on WIDBE and using WIDBE when I started 2 years ago, 2.5 years ago, and the IDE was evolving and changing, and you didn't know from one day to the next, is this going to work or is that going to work or is this going to take me backwards or whatever. So it's actually nice now that WIDBE's out that okay, I have a stable development platform for a while.
Cool.
Yeah.
Excellent. And so the project that you're working on, just to recap, is going to be, or is, component-based. Is it kind of an add-in model for Visual Studio?
Well, I mean, there's sort of two things going on in conjunction here.
Okay.
The one is sort of the project that I'm working on. That's focused on distributed diagnostics and we're still in the defining stage, and I could show you the prototype. I can't show you the prototype, but I could point at the prototype and say, this covers these aspects of the scenario.
Sure.
So there's that, and then there's the idea of building the diagnostic ecosystem up from a series of components, and my project will be built, or certainly use existing components that exist. Like we could take pieces of the debugger, we could take pieces of the profiler, not have to rewrite this from scratch, but basically, design this ecosystem, define the interfaces between the components, and then build my project up from these, and then add additional components as necessary.
True. So I think one of the things we talk about a lot like the power of web services and the power of distribution in the sense that component A doesn't need to know anything about component B. If there's a bridge in the middle called a web service, you're calling this API, it does the work for you. That must add an incredible amount of complexity when somebody on the A side wants to diagnose a problem, which is what we talked about initially, but I just wanted to be explicit about an example.
Yes.
So, and that's what you're working on. So we have two disparate components, or 3 or 4 of them, which is, in the world of distribution, is a great model.
Okay.
None of them know about the innards of it either.
Right.
And there's these web service layers that they interact with.
Right.
So clearly, the diagnostics is going to be happening at that web service layer, correct? Or how is it going to work with a project that B has a problem, some random problem calling into a web service, and something strange happens, and that affects A? It's just an immensely complicated problem that you're dealing with.
So the question is, what's the infrastructure for diagnosing something?
Sure. Like, where do you begin? Like, what's the core of your diagnostic medium?
Obviously, it's one thing to diagnose the problem if it happens for you on your own desktop. The debuggers can step across process boundaries and that kind of stuff. But diagnosing in the actual deployed, in a test lab or in a deployment scenario, that's a completely different story. And I think it's fairly obvious you would need some sort of component or some sort of technology that can collect information, turn on whatever diagnostics or tracing is there, I can't get into too many state secrets, but but there's just stuff is gonna need to actually happen on that box and collect that information, and then the question is then where do you process it and how do you process it? That's a different story.
Absolutely.
But the trick is getting things on that deployed system and not killing performance, because that's something we're also very sensitive to, and I've seen time and time again is that existing diagnostic tools like a bounce checker or a purify or whatever, they work great for the developer, but then they throw it on a deployed system, and they just kill the performance. And so it's like you need to take a different approach. You need to figure out what needs to be collected, or how and how much of it needs to be collected, and can you turn it on or off? And it's a whole multitude of complexities.
Absolutely. Now, clearly, for say Windows, I can see where that deployment would make sense. But what if you have a heterogeneous environment where you have a Linux machine that's doing the core half of the processing, and then how do you then diagnose? So that's another challenge.
That is another challenge. There are some companies out there that claim to be equally adept in Windows and in Linux, and they have their pieces, and like I said, there are tools out there that claim to do these distributed diagnostics, and they do some element of it, but we're coming at it from like the Visual Studio point of view, and we're like what's going to be useful to a developer that has to fix that problem.
Totally.
But in the case of the heterogeneous environment, I think for us, we know Windows, we know that technology, we can do great stuff there, but you can easily see as part of like a component-based ecosystem model that somebody who wanted to write like a Java plugin or something that could emit information in a similar format than what we need, and if it adhered to the activity ID passing conventions, and you can easily imagine where it could be built to build a heterogeneous environment.
Cool.
But like our first focus is get it right on Windows.
Yeah, and the primary focus being making developers' lives easier who work in that model, distributed model. Excellent. Well, we're going to come back. We would love to see some demos.
I would love to show some demos.
And we will, but we'll keep things sort of secret for now.
Yeah.
Still, whet the Niners' appetite.
Yeah, and like I said, we can't stress it enough. We're hiring. If you like the space, if you like simple tables, you like, the ICOR profiler interface. If you like that stuff, give us your resume. We're hiring.
Excellent. Cool. All right.
Well,
it's great to talk to you.
Good checking with you.
Good luck.
All right.
And we'll come back and see how you're doing.
All righty.
Excellent.